Okay, today we're going to talk about carbon dioxide, and we'll do Lewis structure. We'll talk about the shape of the molecule and a little bit of bond hybridization. So this is carbon dioxide. It's got one carbon and two oxygens. So the first thing we need to do is do the Lewis structure. So we've got one carbon, and it has 4 valence electrons, so 1 times 4 is 4. We've got 2 oxygen. It has 6 valence electrons. 2 times 6 is 12. You end up with 16 total electrons. So this has 16 valence electrons that we're going to put into play to make our structure. Now, you could theoretically try to build around oxygen, but carbon needs 4 bonds, so it's usually our building block. If you have a carbon in a molecule, make that your building block. So I'm going to start out with my carbon, and then I'm just going to attach each oxygen there. Okay? And so this oxygen has access to 2. This carbon has access to 4. Now, if I go 2, 4, 6, 8, 2, 4, 6, that's going to leave me short here on the carbon. So I know that oxygen, because it has 6 valence electrons, it wants to make 2 bonds. So I'm going to give 2 bonds there and to the oxygen, and then that finishes my carbon out. And so now I've used 2, 4, 6, 8 electrons. So 16 minus 8 is 8. And then I just distribute the unshared pairs, and everybody's happy. Okay? So you got 2, 4, 6, 8 on this oxygen, 2, 4, 6, 8 on this oxygen, 2, 4, 6, 8 on the carbon, and we're ready to roll. Okay, now this is known as a linear shape. The bond angle is going to be 180 degrees. It's a linear shape. It's 180 degrees. It would be in a straight line, and it also sits flat on the page. A lot of times people get confused with bent, and they try to call bent linear, but if you look back at the water structure, you've got unshared pairs. Now you see there's no unshared pairs here on the carbon, and so that's why we get that 180 degrees in a straight line. Okay? Now, when we're dealing with carbon, the other thing that we like to talk about is the bond hybridization. So how is that carbon hybridized? Okay? Now, there are a lot of different ways to look at it, but one of the easier ways is looking at the bond angle. If the bond angle is 180, we say that that carbon is sp hybridized. Okay? Now, another way to think about it is S and P. That's 2 letters. And in an sp hybridized form, carbon's always going to be attached to 2 things. Okay? So if you think about CH4, I'll just do that one real quick here. H, 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 like that. Okay, when you think about CH4, that is tetrahedral 109.5. And the hybridization is sp3. Okay? And so you got 1 S and 3 Ps, 1, 2, 3, 4, so you got 1, 2, 3, 4 things. So just remember that if the angle is 180, it's sp. If the angle is 109, it's sp3. If it helps you to remember it, that sp is 2 letters, that means carbon is bonded to 2 things and has that 180 linear, that's fine. However you want to remember it. The other one is sp2. I suppose I could do that one real quick here. I don't have much else to do right now. And so when you do this last one, the carbon is bonded to 1, 2, 3 things. It's got an angle 120 degrees. That also sits flat on the table. This one doesn't. That's why you got the dots and the triangle. So that sits flat on the table. It's trigonal planar because it's all in one plane, and that's sp2.